Okay, so we're going to continue solving equations. I haven't put it on the board yet, but Friday you're going to have a quiz on everything that we've been looking at in this chapter. So that'll be on Friday, team. So we're going to continue solving equations, some multi-step ones. The booklet's on top of that metal thing there for the new chapter that we're on. Thank you. It says the steps for solving multi-step equations are: remove brackets using distributive law if applicable. So if there are brackets, you're going to remove them. Collect any like terms on each side of the equal sign, and then isolate the variable and solve for it. So those are the steps that we will follow.
Would more effective writing give you an edge at work? Grammarly can make your job one click simpler. Hi, my name is Maria. I'm a mathematician, and today I'm going to show you how to solve multi-step linear equations. So if I have the equation 2x,
Just a second, I'm going to see if I can raise the volume a little bit here. No, it's as high as it goes. Okay.
Hi, my name is Maria. I'm a mathematician, and today I'm going to show you how to solve multi-step linear equations. If I have the equation 2x plus 4 is equal to 3 times 2x minus 6. What I want to remember is three letters: D, C, I. It stands for distribute, combine, and then use inverse operations. So what I'm going to do is, if I see distribution anywhere, that's the first thing that I want to do. And I see it on the right side of the equation. So I'm going to go ahead and distribute that 3 into everything in the parentheses. So I'm going to get 2x plus 4. And it's so important to bring down every part of the equation that you're not touching to keep everything in order. 3 times 2x is 6x. 3 times negative 6 is negative 18. I'm done distributing. The C that stands for combine means to look on each side of the equation and see if there's any terms that I can combine. On the left side, I have a variable and a number. I can't combine them. They're not like terms. On the right side, I also have a variable and a number, and I can't combine those. They're not like terms. So there's no combinations going on now. Inverse operations. The first thing I want to do is use inverse operations to get the variable on one side, because in this specific problem, it's on two different sides. So what I'm going to do is subtract 2x, because the inverse of a positive 2x is minus 2x. And I'm going to subtract it on both sides to get us on one side of the equal sign. So that's done. Cancels out. I bring down 4 equals 4x minus 18. And I'm going to continue to use inverse operations in order to isolate my variable. So I have multiplication and I have subtraction. You always get rid of addition or subtraction first. It's the easier way to do it. So I'm going to go ahead and add 18 to both sides. The inverse of minus 18 is plus 18. These cancel out. I get 4 plus 18, which is 22, equals 4x. And I'm continuing to use inverse operations. This is multiplication, so I'm going to go ahead and divide by 4 on both sides. And when I do that, I'm going to get x equals 4 goes into 22 5 times with 2 left over, so it's 2 over 4, which is 1/2. So I get x equals 5 1/2. My name is Maria, and I just showed you how to solve a multi-step linear equation.
Okay, so those are the steps that we're going to follow. And then remember, always we're going to check our answers to make sure that the answer we got is correct. So for now, question A, we need to remove the brackets by using distributive property. We're going to multiply each term inside by the 3 that's in front. So the 3 times EX is 3x, and the 3 times the positive 4 is positive 12. So that's our first step. Multiply out those brackets. And now we want to solve for x just like we did over the last few days. Before we can get the x by itself, we have to get the 3x by itself by subtracting 12 from both sides. Plus 12 minus 12 cancels. We've got 3x by itself on the left And on the right, you have 15 take away 12, which is positive 3. And now, to get x by itself, Shyla, what do? Divide both sides by 3. Because 3 divided by 3 is 1, so you're left with 1x, or x, equaling, on the right side, 3 divided by 3, again, is 1. So there's our solution. And that's what we're going to put in our check. Now, yesterday, some of you that handed your assignment in, you lost marks because of your check. Either you didn't do it or you didn't do it properly. You need to show that you get the same number on both sides. It's not enough just to write that line there. Put x, put the 1 in for x and just leave it like that. That's not enough. You haven't shown that the two sides are equal. You actually need to work it out. And even that's not enough. And I agree. You can look at that and say, well, I know that 3 times 5 is 15. But it's not enough. You need to show that you get the same thing on both sides to get full credit for the check. So now we've shown that our answer is correct. Okay? Question B, again, first step is we're going to multiply out the brackets on the left. 5 times m, and then 5 times negative 2. And now in this case, we have m terms on both sides, so we're going to collect them together. And it's always going to be easier if we don't have a negative involved. So because of that, I wouldn't subtract 5m from both sides, because on the right side, 3m take away 5m would give us a negative 2m. So instead, I'm going to subtract the 3m from both sides. So on the right side, the 3m's will cancel. On the left side, 5m take away 3m is 2m. And you still have the minus 10, and then you have the 16 on the right. And now, before we can get the m by itself, we need to get the 2m by itself by adding 10 to both sides. And on the left, the minus 10 plus 10 cancels. That's why we did that step. So we're left with 2m on the left. And on the right, you have 16 plus 10, which is 26. Final step would be to divide both sides by 2. On the left, 2 divided by 2 cancels. You're left with 1m, or just m, equaling 26 divided by 2, which is 13. So there's our answer. That's the number that we need to use in our check. Okay? So again, the equal sign divides our equation into two sides, left and right. We need to show that we get the same number on both sides when m is 13. So on the left, it's 5 bracket 13 take away 2. 13 take away 2 is 11, and 5 times 11 is 55. On the right side, 16 plus 3 times 13. 3 times 13 is 39. And when you add 16 and 39 together, you do get 55. So it checks. This is showing that your answer is correct. Right? Question C, there are no brackets there, but we do have some like terms that we can put together. On the left side, you have a negative 5y and a positive 2y. Those are like terms. They're both y's to the power 1, so we can combine them. Negative 5 plus 2 is negative 3y plus 1. Same thing on the right side. You have a positive y and a positive 3y. 1y plus 3y is 4y. And then you have the minus 6 there still. And now we'll collect the y's so that we only have one y term on one side. And because this is a negative 3y on the left, the best thing to do here would be to add 3y to both sides. Again, we want to avoid any negatives if we can. It'll work if we brought the 4y over. It's just going to be a little bit tougher because you're dealing with negatives. But it would still work. However, if I do it this way, I'm not going to have negatives to deal with. On the left, the negative 3y plus 3y cancel. So we're left with positive 1 on the left. On the right, 4y plus 3y is 7y. Take away 6. Before we can get y by itself, we have to get 7y by itself. So we'll add 6 to both sides. Negative 6 plus 6 cancels. On the left, 6 plus 1 is 7, and that equals 7y. And then we will divide both sides by 7. 7 divided by 7 on the right side cancels. We have y equaling 7 divided by 7 on the left is 1. So that's our answer. And that's the number we need to put in our check. And when you do your check, you always start with the original equation. You see, if you made a mistake in our first step and you use the equation you got in the first step, it would check for that equation, but it wouldn't check for the original one. Always start with the original equation. So we have negative 5 times y, which is 1, plus 1 plus 2 times y, which again is 1, equaling y, which is 1, take away 6, plus 3 times 1. Negative 5 times 1 is negative 5, plus 1, and then 2 times 1 is positive 2. Negative 5 plus 1 is negative 4, plus 2 is negative 2. That's what I get on the left. 1 take away 6 is negative 5, plus 3 times 1 is 3, and negative 5 plus 3 is negative 2. So it checks. Get the same thing on both sides. Our answer is correct. Question D. We've got two fractions there, two denominators. What we want to do first is get rid of the denominators, and we do that by multiplying each term by the common denominator. So we have denominators of positive 3 and positive 4. We need to multiply everything by the least common multiple of 3 and 4, which would be 12. So I'm going to write this out, multiplying the first term by 12 and the second term by 12. So you have to multiply the entire equation by 12. So each term, the 2 on the left, the 1 on the right, has to be multiplied by the same number. Otherwise, you've changed the value of the equation. You see, if you now turned around and divided everything by 12, you've got exactly what you started with. So even though the numbers look different, you haven't changed the value of the equation. But what we've done is we've now got to the point where we can get rid of the denominators by actually dividing. This 12 divided by this 3 is 4x. 12 divided by 3 is 4. And in the second term, the 12 divided by the 4 is positive 3 times the 3 that was there. And that equals 2 times 12, which is 24. Okay, so now you've got 4x plus 3 times 3 is 9 equals 24. Now we'll subtract the 9 from both sides. Before we can get x by itself, we have to get the 4x by itself. So 9 minus 9 cancels, and we have 4x on the left equaling 24 take away 9, which is 15. And to get the x by itself, we would divide both sides by 4. And in this case, we get a fraction for an answer. That doesn't mean it's wrong, but we're going to check to make sure. We'll start with the original equation. And in this case, we're going to use our calculator to help us. So x is above the 3. So it's going to be 15 over 4, all divided by 3, plus 3/4. So here's how you can do this on your calculator. You can go 15 divided by 4 in your calculator. It gives us that decimal. Shyla? And that now needs to be divided by 3, which gives us 1.25. Plus 3/4, which is 0.75. But you don't even have to convert it to a decimal there. You can do it in your calculator by using brackets and putting 3 over 4 inside the bracket. And that equals 2, which is what the right side is. So it checks. We've just shown that our answer is correct. Okay? On the next page, question E. We've got brackets on both sides, so we're going to have to multiply out on both sides. 4 times 3y is 12y. 4 times negative 2 is negative 8. On the right side, 2 times 2y is 4y, and 2 times 4 is positive 8. So there's our first step. Remove the brackets. What now, Keen? Keen, put your phone away. What now? 4? No, there's no 4 there. There's a 4y, not a 4. So you're going to subtract 4y from both sides. Again, by doing it this way, you're going to reduce the chance of having negatives. 12y take away 4y is 8y. And on the right, the 4y's cancel. 4y take away 4y is 0y's are 0. Now what, Kira? Yep. And so you're going to have 8y still on the left. The minus 8 plus 8 cancels. That's 0. And on the right, 8 plus 8 is 16.
I don't know.
No,
But it's also like, this is
that's not mine.
random, but these were. But there's a stack of them. Here.
I have no idea where those came from.
They were just like I found them, and then this was there, which I thought was really weird. Anyways, they're just like downstairs, like on my way out the door last night at 8:30. So I was like, I don't know who this is
Like
or
this
why.
is from September.
Oh, so super weird.
Okay. Well,
So
thank
and
you.
then I'm assuming that this is probably like Lee. It's just like it was a very weird stack of stuff. And I'm like, I'll just take it because I don't know why or.
Okay. Thanks so much.
Yeah, no worries. Have one.
Yeah. And now to get y by itself, we'll divide both sides by 8. So the 8's cancel on the left, and on the right, 16 divided by 8 is positive 2. So now we'll do our check. We have 4, and I'm going to use big square brackets here only because I'm going to use round brackets inside to show that I'm letting y equal 2. Shyla, put your phone away. So as we're working through this, we need to work inside the brackets first. 3 times 2 is 6, and 6 take away 2 is 4. And then 4 times 4 is 16. On the right side, inside the brackets, 2 times 2 is 4, plus 4 is 8. And again, 2 times 8 is 16. So we get the same thing on both sides. We've just shown that our answer is correct. Okay? Now, for question F, we've got a fraction on each side, a single fraction on each side. So what we can do here is just cross multiply, which would give us the same effect if we multiplied both sides by the common denominator, which in this case would be 35. It would be the same effect. But because there's only a single fraction on each side, it's true that the fraction on the left has 2 terms on the top, but that's part of one fraction. And same thing on the right. That x minus 6 is part of one fraction. And whenever 2 fractions or 2 ratios are equal to each other, their cross products are always equal. So this is why that is a true statement. If you take the fraction 1/2 and 2 over 4, those are equivalent. They have the same value. If you divide 1 by 2, you're going to get 0.5. And if you divide 2 by 4, you're going to get the same decimal. They're equivalent. You can go from the first fraction to the second by multiplying them both top and bottom by 2. So when 2 ratios are equal to each other, their cross products are always equal. Their cross products are always equal. So 1 times 4 is 4, and that equals 2 times 2. When 2 ratios are equal to each other, their cross products are always equal. Let's look at a different example. Let's say we had 3 over 15, and if we multiply both top and bottom by 3, we'll get 9 over 45. So those have the same value. 3 divided by 15 is that decimal. 9 divided by 45, same decimal. They are equivalent, which means their cross products will be equal. 3 times 45 is 135, I think. 3 times 45. Yep. And that should equal 15 times 9. And it does. Whenever 2 ratios are equal to each other, their cross products are equivalent. So we'll do the same thing for question F. Because we have 2 fractions or 2 ratios equal to each other, their cross products will be equal. So it doesn't matter which one you do first. I'm going to do the 5 on the bottom on the left will equal the x minus 6 in the top right, and that must equal. Their cross products are equal. 7 on the bottom right times x plus 2 on the top left. So now when I multiply out the brackets, what do I get, Shyla? Do you have a late night? Bad sleep? Just tired? Because life is so hard? What do we get next? Yep. Equals? Okay, thank you. I asked you because I know you know the right answer. Because Princess has been helping you a lot. I know she has. Huh? What now, Keen? Yes. And you want to do it this way so you don't get negatives. You could subtract 7x from both sides and it would work, but that would give you a negative 2x on the left side. And we want to avoid those if we can. So you're left with negative 30 on the left, and this is important. The sign in front of the 30 is negative. It's got to stay there. On the right side, 2x take away 7x take away 5x is 2x plus 14. Now what, Charlie? Yep, and how? Good. And again, you need to be careful here because on the left side, it's negative 30. Negative 30 take away 14 is negative 44. And we've said this before, you might use your calculator to help you. Negative 30 take away 14 gives you the negative 44. And we're left with 2x on the right side. And then finally, we would divide both sides by 2 to get x by itself. Negative 44 divided by 2 is negative 22. That's what x equals. And so that's what we're going to put in our check. And again, for your check, you always start with the original equation. Did you sign in? Thank you. So x is negative 22. You're going to have negative 22 plus 2 all over 5. Negative 22 plus 2 is negative 20. Divided by 5 is negative 4. On the right side, negative 22 take away 6 over 7. And negative 22 take away 6 is negative 28. Divided by 7 is negative 4. So it checks. It checks. Our answer is correct. All right, looking at question G. You've got a fraction on the left. We can make the right side a fraction by putting it over 1. So if I rewrite this out, and while I'm doing this, I'm going to multiply out the brackets on the right. Negative 2 times x and negative 2 times 4. But I put it over 1. So now I've expressed both sides as fractions. There are single fractions on both sides. So we can cross multiply. That's going to be my next step. 1 times 2x minus 1 has to equal 3 times negative 2x take away 4. When I multiply out, 1 times 2x minus 1 is just 2x minus 1. On the right side, 3 times negative 2x is negative 6x minus 12. When you multiply out the brackets. And because we have a negative 6x on the right, I would add 6x to both sides. Two x plus 6x on the left will equal 8x minus 1. And on the right, the negative 6x plus 6x cancels. You're left with negative 12. And now if you add 1 to both sides, you're going to have 8x equaling negative 11, and then divide both sides by 8, and x will equal negative 11 over 8, a fraction. But that's okay, because we're going to use our calculator to help us do the check. So on the left side, we'll have 2 times negative 11 over 8, take away 1, all over 3. And again, we're going to use our calculator to help us do this. 2 times, and I'm going to use brackets here, negative 11 divided by 8 is negative 2.75. So it's going to be negative 2.75, take away 1, over 3. Negative 2.75 take away 1 will be negative 3.75. And when you divide that by 3, you'll get negative 1.25. So that's what I get on the left. And I need to get the same thing on the right. So it's negative 2 times negative 11 over 8 plus 4. So with my calculator, got to do what's inside the brackets first, and I'm going to put the negative 11 over 8 inside the brackets to keep it together, but then I have to add 4 to it. So that'll be negative 2 times 2.625. This isn't going to work. I've got a mistake somewhere, I think. Negative 11 over 8 plus 4, because when you multiply that by negative 2, you're not going to get negative 1.25. So here's why the check is so important. When you multiply this by negative 2, you don't get the right answer. So let's go back, and I'm going to check the left side first and make sure I put everything in the calculator correctly in my check. So 2 times x, take away 1 over 3, so this is correct. Then now I'm going to check this by, again, going in brackets, negative 11 divided by 8, put that in brackets, times 2, negative 2.75 is correct, minus 1 is negative 3.75, divided by 3. So I did everything correct in my check. So my mistake has to be somewhere when I actually solve the equation. So we'll go back and check and see where that is. I've got the 2x minus 3, 2x minus 1 over 3 equaling, when I multiply this out, negative 2 times x is negative 2x, negative 2 times 4. There's my mistake right there. That's negative 8. That's negative 8, not negative 4. So, and I have to go back and refinish this, or redo it. And sometimes that happens. And that's why the check is so important. So now when you cross multiply, it'll be 3 bracket negative 2x minus 8 equals 1 times 2x minus 1. It'll be negative 6x minus 24 equals 2x minus 1. And now I will add 6x to both sides. So the negative 6x plus 6x cancels. And we have negative 24 on the left equaling 2x and 6x is 8x minus 1. We'll add 1 to both sides, and that'll give us negative 23 on the left, equaling 8x. And then divide both sides by 8, and x will equal negative 23 over 8. So again, a fraction, but that's okay, because we can use our calculator to help us check. So we'll do it again. 2 bracket negative 23 over 8 is negative 5.75. Take away 1 is negative 6.75. Divided by 3 should be negative 2.25. Yep, negative 2.25. So now on the right side, negative 2 bracket, and it's negative 23 over 8 plus 4. So in brackets, I'm going to go negative 23 divided by 8, just to keep that fraction together, plus 4. It'll be negative 2 times 1.125. And when you multiply that by negative 2, we get the right number. Same as was on the left, negative 2.25. Again, this shows the importance of doing the check. Making sure that the answer you get is the value that makes the equation work. Okay? Question H. What I would do here first is I would add this 6 to both sides. That will get the fraction by itself on the left. And while I'm writing it down, I'm going to do the multiplying here, distributive property, multiplying the x plus 3 both by the 4. There's this 4x plus 12 over 3, and that will equal, on the right side, 10 and 6 is 16, which I'll put over 1. So now I have both sides as fractions, like I've done before. I can now cross multiply. 1 times 4x plus 12 equals 3 times 16 when you cross multiply. Or 4x plus 12 equals 48. Because 3 times 16 is 48. And now we can subtract the 12 from both sides. They'll cancel on the left, and you'll have 4x equaling 36. Divide both sides by 4, and x equals 9. 36 divided by 4 is 9. So there's our answer, and that's the number that we're going to put in our check. And again, you always start with the original equation. Because if you made any mistake when we started working on simplifying that equation, and you don't start with the original equation as your check, it might check, but it doesn't check for the original one. So x is 9, so it'll be 9 plus 3 all over 3, take away 6. The right side is 10. We need to get 10 on the left as well. So inside the bracket here, 9 plus 3 is 12. Four times 12 is 48. 48 divided by 3, I think, is 16. Yep. And 16 take away 6 is 10. So it checks. It checks. Our answer is correct. We just showed that it is. All right. So these last two are not one single fraction equaling another single fraction, right? For question I, there are two fractions on the left of the equal sign. So this is one of those ones where we need to multiply each term by the common denominator. If you look at the denominators of 2, 2, and 4, the least common multiple of those numbers is the number 4. So we're going to multiply everything by 4, all of the terms by 4. Because that is our common denominator. And the reason we do that is because we can do some canceling now. This first term, 4n divided by 2. 4 divided by 2 is 2, so you're left with 2n plus. Again, 4 divided by 2 is 2 times the 1 is 2. And for the last one, the 4's cancel. 4 divided by 4 is 1 times the 3 is 3. So that's the equation that we're now going to solve. We'll subtract the 2 from both sides. And you're left with 2n on the left equaling 1 on the right. And then when we divide both sides by 2, n will equal a half. There's our answer. And that's the number that we need to put in our check. If you take your calculator and you find out what 3/4 is as a decimal, it's exactly 0.75. It's a terminating decimal, so we can use that. On the left, we're going to have 1/2 over 2 plus a half. So 1/2, I'll put that in brackets. And if you want, you might remember that 1/2 is 0.5, so you can just use that. But either way, it has to be divided by 2. So it's 0.25 plus a half, which is 0.5. That does equal 0.75. Plus 1 divided by 2 is 0.75. So it checks. We've shown that our answer is correct. Right? Question J is similar because you've got 3 separate fractions. So again, you're going to have to multiply by the common denominator between all 3 denominators. The least common multiple of 2, 3, and 4 would be 12. So that shows that we're multiplying all the terms by 12. And the reason we're doing that is so that we can actually divide now and get rid of the denominators. 12 divided by 2 is 6 times the n plus 3. Plus 12 divided by 3 is 4 times the 1. And that equals 12 divided by 4, which is 3 times the n. So I'm going to multiply out the brackets here. 6 times n plus 6 times 3 is 18. Oh, this is 6 times n is 6n plus 6 times 3 is 18 plus 4 times 1 is 4 equals 3n. So on the left, 18 and 4 is 22. And in this case, I am going to subtract the 6n from both sides. It is going to give me a negative on the right, but that's okay. It's just going to save me a step. So on the left, the 6 ends cancel. You're left with positive 22 on the left. On the right, 3 take away 6 is negative 3n. And now we will divide both sides by the negative 3. And we're going to get a fraction for an answer, and that's okay, because we're using our calculator to help us anyways. And we can write it like 22 over negative 3, or we can just say it's negative 22 thirds. When a fraction is negative, either the top or the bottom is negative. It doesn't really matter which one or where we write it. So now, to use our check, we'll start with the original equation. N plus 3 all over 2 plus 1 over 3 has to equal n over 4. And n is 22 over negative 3. So on the left side, you've got 22 over negative 3 plus 3. So again, I'll use brackets. I'll put the 22 divided by the negative 3 in the brackets, and then I'll add 3. That gives me a repeating decimal, and that's okay, because I'm going to divide it by 2. So that gives me negative 2.16 repeating, which I'm going to write down like that. But then I'm going to use my calculator to add 1/3 to it. So plus, in brackets, 1 over 3. And it gives me negative 1.83 repeating. And that's okay, because we should get the same answer on the right side, which is 22 divided by negative 3. And if you divide that by 4, you get the same decimal, negative 1.83 repeating. So we've shown that our answer is correct. It doesn't matter if you get a fraction for an answer, you can always check it using your calculator. Okay, so remember, the assignment from yesterday is due for marks. So if you weren't here, you need to come and get it. It's at the front here on the desk. And we're going to have a quiz on this stuff on Friday.